So let's look at a thermal decomposition, an example that is. So first thing first, let's identify what is that we're looking at. CaCO3. It has a name and that is calcium. We have a carbon, calcium carbonate. Next, CaO. This too has to do with calcium, but we have oxygen, so calcium oxide. CaO2, that you guys know, carbon dioxide. Okay, now let's balance it out. So the funda here is, again, I'll repeat, write all the product and the reactants at the top. Since I have space, let me actually do that properly. And write all the atoms that are part of this reaction. This is O. Now, the question is, in CaCO3, how many calcium is there? That is 1. How many carbon atoms are there? 1. Oxygen, there are 3 of it. And in CaO, there is 1 and none and 1 over here. And in CO2, we have none, 1 and 2. The question is this balanced? 1 plus 2 is 3, okay. 1 and 1, okay, and okay. So this is a balanced equation. Of course, we have quite a bit of information missing over there, that this is solid. And we need to heat it. And then we'll end up with CO, which 2 is a solid, and CO2, which is a gas. This is, we're helping this with providing a source of energy, heat, in the form of heat, right? Now, how do we get to know? We saw that there is gas formation. Then we have the change in solid form, right? Solid, they look different. After this set of reaction, they look different. And this is an endothermic, that is, it's tough to find it out, but yes, you can feel that it is cooler. It will take in energy. It needs energy for this to happen. So this is an endothermic reaction. Now, let's look at the reaction itself. CaCO3. What kind of bond this would be? Yes, this will be an ionic bond. Let's look at this. Why is that? So we have Ca over here, right? And oxygen and carbon over here. Okay. So Ca will, interact with CO3 twice basically. CO3, that is 2 minus. So they have a difference which leads to an ionic bond. So we can see the Ca value, electronegative value is 1, and this 2, when they react and form an intermediate product, the reaction among them leads to an ionic bond. Now, CaO itself, the difference is 2.44. So that too will be an ionic bond. CaO is also an ionic bond. And of course, CO2 is an covalent bond. CO2. And I can show you guys over here. CO2. So the difference here is less than 1. So this forms a covalent bond, polar covalent bond. Okay, so basically, why does it happen? Quite obvious, we are providing heat, and heat leads to, right? We are providing things with heat. When we heat it up and we have supplied with enough heat, there's enough energy, bonds are broken. So further, it leads to CaO combining while CO2 escaping. That's the most simplest way I can put it across. So why do we need, how can we tell that this is an endothermic reaction? Because in this case, CaCO3 right? It starts at a higher energy level. Okay, so CaCO3. Okay, sorry, I was telling the other way around. So we have CaCO3, which is at a lower energy level, and we have CaO and CO2 at higher energy level. These are basically, this is more stable compared to this. So moving from higher to lower to higher, what happens? We need energy. And so this is an endothermic reaction. Okay, that's one of the ways of understanding it. So this is your CaCO3 getting decomposed.